All right, hey everyone, welcome back to a new week. We have a new lesson. Today it's going to be about even and odd functions, and your aim for today is how do we categorize functions as even or odd. Today's homework is going to be number 10, and it's going to be on a handout, numbers 55 and 56, which I want you to graph. And for numbers 61 through 68, I want you to prove it, but you don't have to graph as it does say in the instructions. So just prove these 61 to 68, but you don't have to graph these. Okay. So the objectives, let me just read it for you. Students will be able to, 1, describe the symmetry of the graph of a function, 2, categorize a function as odd, even, or neither based on symmetry, 3, prove that a function is odd, even, or neither algebraically, 4, determine if a function is odd, even, or neither by inspection. And then the last one is relate whether a function is odd, even, or neither to the powers of the terms of the function. Okay. All right, let me start off with the do now, which is going to be on the slide here. All right, so sketch the graph of the following function, not by using your calculator, but by starting with the graph of a standard function and applying transformations. Specify the standard function and list the transformations you apply. Okay, so as you can see, it's y equals 5 plus x plus 3 squared. The standard function, or another word for that is parent function, or in our OpenStax textbook, they call it a toolkit function. In this case, it's going to be x squared, right? But as we can see, it's transformed, right? It's been shifted horizontally and vertically. Okay, so think about it for a sec, and I'll go to the solution right now. All right, here we are. So here's the answer. Let me type that up actually, answer. Okay, so shift the parent function y equals x squared. As you remember from the last lesson, right, it's going to be left 3 units, right? So plus 3 is the left actually, right? It's counterintuitive, right? Horizontal transformations are counterintuitive. Vertical transformations are intuitive. Okay, so vertical is it's what you think it is. Okay, so this plus 5, don't be confused because it's on the left, right? But that'll shift up 5 units, right? We're just adding 5 to the outside of the x, right? So since x plus 3, that's contained, right? The 3 is like attached to the x variable. That'll be a horizontal transformation. And as we know, it's left 3, and then this is up 5. Okay, so here I also write that the new vertex will be negative 3, 5. And here's what I would draw. Here's what I would sketch, right? So you don't have to be too precise, right? Just a sketch. So the original function is at the origin, right? The vertex at the origin, I mean. And then we're going to shift left 3 units and then up 5. Okay, so the new vertex is negative 3, 5. And that's this graph in red here. Okay. All right. For the rest of the video, let me show you what we're going to do. Okay. So we're going to talk about even functions right here. Right. And then I'll show you the definition, and then a couple of follow-up questions with regards to even functions. And then we'll move on to odd functions. Same thing, follow-up questions. And then we'll close with our worksheet. Okay. All right. So let me get to the slides here. All right. Here's the definition. So please copy this down in your notes. That. All right. So if a function f satisfies f of negative x equals f of x for every number x in its domain, then f is called an even function. And note that the graph of an even function is symmetric to the y-axis. Okay. So you might be getting a flashback from last year, right? This is an algebra 2 topic, but it's an important one, so we're going to emphasize again here in pre-calc. And if you need to copy this definition down or need more time, please pause video here, otherwise I'll keep moving. Okay. And then as you can see, the follow-up question to that was show that it's an even function. Okay, and which we're going to do algebraically, and then next we have our odd function, but I'll show you that fully after we cover this example. Okay, all right, going to scroll up to the solution. All right, so that question was, okay, so show that f of x equals x squared is an even function. Okay, so to show it algebraically, we have to just plug in negative x, right? Just based on the definition, just plug in negative x, and then we have to show that it's equal to the original function. Okay, so the original function that we should end up with, x squared in this case, right? Okay, so if you plug in negative x here, you get negative x squared, right? That entire thing squared. And negative x you can see as negative 1 times x, which I write in this step. And that's the entire thing's being squared. And then, as we know, the square of a product, right, this product here is being squared, is equal to the product of each of those terms squared. Okay, so it's negative 1 squared, right? We just distribute, quote unquote, like distribute the square, right? Negative 1 squared times x squared. Negative 1 squared is positive 1, so we just get x squared. Okay, and voila, that's actually equal to x squared, as we expect, right? It's an even function. Okay, and then next we're going to talk about the graph. So this wasn't on the slide, but just a follow-up question. Using f of x equals x squared, explain why f of x is symmetric to the y-axis. Okay, this concept will be important, right? So the y-axis symmetry is important for a couple of the questions on the homework tonight. And then the answer is, if we have plotted the graph of f for x is greater than or equal to 0, so that's like the right-hand portion of the graph, right-hand half, right? So this part here. Then we can obtain the entire graph simply by reflecting this portion in the y-axis. Okay, so if you reflect this part in the y-axis, you get the other half, and then that completes the product. Okay, so yeah, x squared is an even function, symmetric about the y-axis, and yeah, you can see that right here. Okay, all right, I'm going to move on to odd functions. Okay, for that, I'm going to go back to the slide for the definition. But if you need to copy any of this, please pause the video here. All right. So, all right, next definition was with regards to odd functions. If a function f satisfies f of negative x equals negative f of x for every number x in its domain, then f is called an odd function. Note that the graph of an odd function is symmetric about the origin. This is equivalent to reflecting in the x-axis and the y-axis. Okay, and then the follow-up example is show that x cubed is an odd function. Okay, if you need to pause the video here to copy it down, please do so right now. Otherwise, I'll move up to the solution of this question. All right, here we are. All right, so we're gonna show that it's an odd function by the same way, right? That we did that we showed x squared was even, right? Just plug in negative x. Okay, so negative x cubed, right? You can see negative x as negative 1 times x, right? Just like the last example, and that entire thing is being cubed. And we, just like the last example, we'll distribute the cube, right? So we're going to distribute the exponent right there, and then negative 1 cubed is negative 1, right? Negative 1 times negative 1 times negative 1. Or negative 1 times negative 1 is positive 1, and then positive 1 times negative 1 is negative 1, and then we'll have x cubed, right? So negative x cubed and negative x cubed, and that will be equal to negative f of x. Okay, and so because we showed that after plugging negative x, we get the negation of the original function, we proved algebraically that this is odd. Okay, and just to talk briefly about the graph. So using f of x equals x cubed, explain why f of x is symmetric about the origin. Okay, so this means that if we've plotted the graph of f for x greater than or equal to 0, so again, this right-hand portion, then we can obtain the entire graph simply by rotating this portion through 180 degrees about the origin. So if you rotate 180 degrees, right? So remember, positive angles in math are counterclockwise, so we're going to rotate this way, and we'll get that bottom portion. Okay, another way you can see that, I know it's kind of hard to visualize, right? So another way to see that is by reflecting. Okay, so this is equivalent to reflecting in the x-axis and the y-axis. Okay, it doesn't matter the order, so, but I'll just follow this order right here. So x-axis, right, you reflect over the x-axis, that'll end up here, and then you reflect in the y-axis, that'll end up there, right? And yeah, just to show you, right, if you reflect it in the y-axis first, it would end up here, and then the x-axis, you would end up in the same place. So yeah, just keep this in mind when you're completing the question on the homework. It was actually, let me show you now which question it was. It was numbers 55 and 56. So you're going to have to complete the graph for x less than 0 to make it an even function and an odd function, right? So remember, even functions reflect over the y-axis, odd functions reflect over the origin. Another way to break that down is reflect in both the x and y axes, okay? All right, back to the lesson. So, sorry, I'll give you a chance to copy that part down. Okay, so yeah, if you need to copy any of this part down, please pause the video here. Otherwise, I'll move on to the worksheet, which I believe is next. All right, yes, yeah, the worksheet. Okay, so let me show you an overview of the worksheet. So, all right, sorry, it's right here. Okay, so first question is determine whether functions are even, odd, or neither. And yeah, just like the two examples that we just saw, right? We're going to plug a negative x and then evaluate. And then question 2, we're going to graph 3 functions from question number 1 on our graph calculators, and we're going to use a viewing window of -3 to 3 and -2.5 to 2.5 for the vertical axis to verify each graph symmetry. Sketch the graphs below. Okay, we'll do that next. And then 3 and 4 don't have to do with even and odd. Number 4 has to do with transformations, by the way. And then question number 3, just an exercise in graphing. Okay. All right. With that said, though, let me get to the solutions. All right. So question 1. So yeah, as I said, we're going to just plug in negative x, right? So we'll have negative x to the 5th plus negative x. So negative x to the 5th. By now, hopefully you're realizing that negative x or any negative number to an odd power, an odd, like odd as in like this number is 5, right? Which is an odd number. Anything raised to an odd power, or sorry, I should say any negative number raised to an odd power, right, is going to be negative. Okay, so we're going to get negative x to the 5th, right? If you want, you can test that out, right? Negative x times negative x times negative x times negative x times negative x, right? That's negative x to the 5th. Same thing for like -1 or -2, right? Okay, and then we're going to get that negative x is just negative x. We don't have to do anything there. And then just to show that this is negative f of x, right, we can factor out a negative sign, or -1, right? So we get negative times x to the 5th plus x. So this thing right here in the parentheses is f of x. And then we see that it's the negation of the original. Okay, so therefore this is an odd function. Okay, part B, we have 1 minus x to the 4th as our function, and we're going to plug in negative x, right? And then so we're going to get 1 minus negative x to the 4th, and we'll get 1 well, negative x to the 4th, so negative x or a negative number to an even power is positive, okay? So this will be 1 minus positive x to the 4th, right? So it doesn't change, right? So it'll just be x to the 4th. Yeah, so that's equivalent to the original function. So therefore, 1 minus x to the 4th is even, okay? And hopefully by now you're noticing a pattern, right? So it has to do with the exponents, right? So all right, x squared we saw earlier was even, and same thing here, right? X to the 4th, right? 4 is an even number, right? This is also an even function, right? And I know you don't be thrown off by this 1 here. So this 1 you could see as x to the 0, right? All right, so just note, yeah, I'll write here. So note that 1 equals x to the 0. Right, so we can see that 1 minus x to the 4th is the same thing as x to the 0 minus x. Okay. Okay, so as you can see, right, both these powers are even, right? 0 is an even number, as is 4. Okay, and then yeah, for the odd functions, right, this is odd, right? 5 is an odd number, and this can be seen as x to the 1, right? 1 and 5 are both odd numbers, so this is an odd function, and that pattern will work. And yeah, you're going to see that in the next function, right? So this next function is neither. Okay, we're going to plug a negative x, right, into 2x minus x squared. So as you can see, this is x to the 1 minus, right, x squared, right? So there's 1 and 2, right, which don't match up. It's neither even or odd, right? So that's cool, right? It matches with the exponents. So yeah, that's another way to tell whether or not the function is even or odd. Okay, but yeah, back to the algebra. So it's 2 times negative x minus negative x squared. So that'll be negative 2x minus negative x squared is x squared, right? So it'll be negative 2x minus x squared. And as we can see, right, it's not equal to the original function, right? It's not equal to 2x minus x squared, right? Because we have this negative sign here. And just be extra clear about it. Negative h of x, show that this is not odd either. That would be equal to, right, if you just negated the entire thing, that would be negative 2x plus x squared. And I guess I should write that in the next line. Okay. So it's neither, since h of negative x is not equal to, oops, trying to get the inequality sign here. Okay, h of negative x is not equal to the original function, so therefore it's not even, and it's not equal to a negative h of x, okay, which would show that it's odd. All right, so therefore this is neither. Okay, so sorry, just change the formatting a little bit, and okay. All right. Question 2. So we're going to graph the 3 functions from question number 1 on our graph calculators. And yeah, we can confirm. So I have the answers here actually, but let me show you for one of them. So remember the 3 functions were x to the 5th plus x, 1 minus x to the 4th, and 2x minus x squared. Okay, so as you can see, right, x to the 5th plus x, this is an odd function, so it should have origin symmetry. Right, so if you reflect over the x and y axes, right, the right hand portion, then you'll get the other portion, and you'll get the entire graph, right? And then this has y-axis symmetry. Yeah, so as you can see, it just splits down the middle, and this has neither, right? It's neither symmetric about the y-axis because, right, that doesn't get split in half. And then if you reflect the right hand portion, right, just like this part, over the x and y axis, then you don't get the other half, right? Okay, so yeah, that's neither. But yeah, just confirm that, or to show you on the calculator. Let me share that. Okay, so yeah, I'll do the let me do the last one actually. And sorry, I'm having the same problem. Okay, so let me restart that calculator. Okay, I think it should work now. All right, here we are. Okay, so hopefully you can see it. Let me do the last function. Okay, that's the neither one. Okay, so let me clear these. Okay, so we have 2x minus x squared. Okay, and then the viewing window that they want us to have is -3 and then 3. Okay, that's a 1, and then -2.5 and then 2.5. All right, graph this. Yeah, as you can see, right, same graph that we saw earlier, right? But yeah, that's how you would use your graph calculator for that. Okay. All right. Okay. But yeah, if you needed to copy any of this, the solutions to 1 or 2, please do so right now. Okay. I'm going to be moving on to questions 3 and 4. Okay. All right. Question 3. So we have the graphs of f of x equals x squared minus 4 and g of x equals the absolute value of x squared minus 4 are shown below. Explain how the graph of g of x is obtained from the graph of f of x. Okay, so as you can see, right, there's this graph here, there's this other graph here. This one is absolute value of this function. And yeah, so as we know, the absolute value functionally, right, it just makes everything positive, right? But I mean, by definition, the absolute value is a number's distance from the origin, right? So yeah, absolute value of -3 would be 3, right? Because the distance from -3 to 0 is 3. Okay, but anyhow, yeah, we're just going to change all the negative values to positive. Okay, so this portion, right, is negative. So we're going to change that to positive. Okay, and then that's how we get this pink graph. Okay, but yeah, I explain it in words here, right here. So since f of x equals x squared minus 4 is less than 0, right, for -2 to 2, right? So for any x value between -2 and 2, it's going to be negative, right, this graph. The graph of y equals g of x is found by sketching the graph of y equals f of x for x less than or equal to -2 and x is greater than or equal to -2. Sorry, and x is greater than or equal to 2. Then reflecting in the x-axis, the part of the graph of y equals f of x for -2 is less than x is less than 2. So x is between -2 and 2. Okay, so I know that was a lot, but it's actually not too complicated. It just looks complicated because of, we have to be mathematically precise here with our intervals. Okay, so, but yeah, we're gonna sketch the graph. We're gonna sketch this graph in blue for x is less than or equal to -2, so that's this part here. And x is greater than or equal to 2, that's this part here. And then everything in between, so any x value between -2 and 2, we're going to reflect, as it says here, in the x-axis. Okay. All right, but yeah, that didn't really have to do anything with even and odd functions, just an exercise in graphing. Okay. All right, last but not least, we'll go to question 4, which has to do with transformations. Okay, so just a review question here. All right, so here it says the temperature on a certain afternoon is modeled by the function c of t equals 1/2 t squared plus 2, where t represents hours after 12 noon, and t is between 0 and 6 inclusive, and c is measured in degrees Celsius. Okay, so yeah, between 0 and 6 means that we're only going up to 6 p.m., right? All right, part A is what shifting and shrinking operations must be performed on the function y equals t squared to obtain the function y equals c of t. Okay, so we're gonna just think about the transformations, right? So as you can see, there's a 1/2 in front of the t squared, that's the vertical stretch. And then there's a +2, so that's a vertical shift, right, up 2. But yeah, I'll show you the answer in just a bit. Part B is, suppose you want to measure the temperature in Fahrenheit instead. What transformation would you have to apply to the function c of t to accomplish this? Use the fact that the relationship between Celsius and Fahrenheit degrees is given by, yeah, there's a formula that you might know from, science class, right? F equals 9/5 Celsius plus 32. And lastly, we're going to write the new function that results from this transformation. Okay, so part A, the answer was the graph of y equals t squared must be shrunk vertically by a factor of 1/2. Okay, so that's just 1/2 t squared here. But as we know from the previous lesson, right, we shrink by a factor of 1/2, right? Every y value gets halved. Okay, so it's gonna look like everything, yeah, every value like decreased, right? And shift it up 2 units to obtain the graph of c of t. Okay, so that's from here, right? Okay, and actually, let me backtrack. So not every value gets halved, or not every value decreases, but right. So I guess if you'd have 0, 0, right, that if that's on the graph, then that wouldn't get decreased. That would stay the same. But anyhow, yeah, you guys know what I mean. That's your answer for part A. All right, part B, the graph. So yeah, we're just analyzing this graph now, or this function. right here. So the graph of y equals c of t, right? So this Celsius function is being transformed, right? It must be stretched vertically by a factor of 9/5 and shifted up 32 degrees to obtain the graph of f of t. Okay, so that's your answer for part B, right? Pretty simple, pretty much the same as A, just different numbers. And lastly, we have part C, write the new function that results from this transformation. All right, so this is just, we just plug in, right, this function here into this function, right? So c of t equals 1/2 t squared plus 2. So we're going to plug that expression into here, c, right? And you'll see what we get. Okay, so we get 9/5 times 1/2 t squared plus 2, right? That's that c function, and then plus 32. Just multiply 9/5, distribute it, right? We get 9/10 t squared, right? That's here, and then plus 18/5. Okay, so 9 times 2 is 18, right? 18/5, and then 32, which I actually changed to excuse me, which I changed to 160 over 5 because I know that we have to add this right in the next step, right? So 32, we need that 5 in the denominator, so 32 times 5, right? Well, 30 times 5 is 150, and then 2 times 5 is 10, so we get 160 in total, right? 150 plus 10. Okay, so last step, we just add, right? So 18 plus 160, that's 178. And your final answer is 9/10 t squared plus 178 over 5. Okay, which I guess, actually, let me write that as this, right? We need a function, not an expression. Okay, we need an equation, I mean. Okay, so that's your final answer for part C. Okay, so if you need to copy this solution, please pause the video here. Okay, all right, and then I'm not sure if I pause the video here, but yeah, this is the solution to question 3. So if you need to copy this down, please pause video here. Okay, but otherwise, that's all I want to say for today. And yeah, just remember to submit your homework. I'll see you guys in the next lesson. Have a great rest of the day.